Good morning, fourth grade students of 502. It is time for Eureka Math. And we all know by now that Eureka is Latin. Translated to English means I have found it. And what have we found? We have found the best way to learn math, and from what I understand, that is more valuable than gold. Let's hop right to our objective. We're going to be solve additive compare word problems modeled with tape diagrams. And you'll understand what that is about as we delve into our lesson. I'm going to start off with something new. 1 kilogram equals blank grams. Once again, the copy machine is still down, so you don't have to write that, but you can certainly write this. Now, a kilogram. What is a kilogram? It's a metric unit of weight. The standard unit of weight is in pounds and ounces, but the metric folks do it in grams. Okay? So 1 gram, and I'll prove this to you later on, 1 gram weighs about as much as your standard paperclip. So a kilogram would equal how many grams? How many of these? It equals 1,000. So 1 kilogram is 1,000 of these little bad boys. All right? Kind of going a little bit different than what we were doing with the centimeters and meters and all that good stuff. So let's continue on. And we'll do 2 kilograms equals blank grams. And you could fill in the blanks if you're comfortable. If not, wait till you see what Mr. Lega does. 3 kilograms equals blank grams. 8 kilograms equals blank grams. We'll do 8 kilograms. 500 grams equals blank grams. Let's continue on with 7 kilograms. 500 grams equals blank grams. And finally, 4 kilograms, 250 grams equals blank grams. So you could go ahead and write those down. Some of you might be tempted to fill them in as you go. That's okay. We're going to do that right now. So if 1 kilogram equals 1,000 grams, 2 kilograms must equal what? Well, if you thought 2,000, or you already wrote that down, 2,000 grams, you're absolutely right. 3 kilograms, 3,000 grams, or 3,000 standard paper clips. Imagine that. 8 kilograms equals 8,000 grams. 8 kilograms, 500 grams. Seems to me that that would equal 8,500 grams. 7 kilograms, 500 grams would be 7,500 grams. And 4 kilograms, 250 grams would be 4,250 grams. And we can take a look at this as a number bond. Let's do that. We'll come up here, kind of a number bond. Let's put 1,500 grams up here. I'm going to break that apart. Let's break it apart to 1,000 grams. And what else? Well, the 500 grams, of course. 500 grams. And we'll give it another try with 2,500 grams. I forgot my comma there. 2,500 grams, we'll break that up into 2,000 grams and 500 grams. We see that? 2,500. Do a couple more. If you get the hang of this, we'll do 9,500 grams. Break that up into 9,000 grams and 500 grams. And finally, we'll do 7,250 grams, 7,000 grams, 250 grams. So you can see how that works. 1,500 grams is 1,000 grams, 500 grams. 2,500 grams, 2,000 grams, 500 grams. 9,500 grams, 9,000 grams, 500 grams. 7,250 grams, 7,000 grams, 250 grams. There you have it. Let's continue on with our application problem. We're going to underline what we know and circle what we'll be dealing with. So bakery used 12,674 kilograms of flour. I have a feeling that's going to be our whole. Of that, 1,802 kilograms was whole wheat and 880 kilograms was rice flour. Let's circle those numbers. I have a feeling they will come into play. The rest was all-purpose flour, regular old white flour. Say, how much all-purpose wheat flour or all-purpose flour did they use? We're going to solve and check for reasonableness of your answer. That means we'll be doing a little estimating and rounding too, all right? So let's start off with our tape diagram. And look at our problem. What's going to be our whole? Well, of course, the total amount of flour, which was 12,674 kilograms. All right. So now we're going to put in how much whole wheat flour and how much rice flour they use. So let's break a section for the whole wheat. And the whole wheat flour, how much of that was used? If we look there, we see we circled that number, 1,802. And how much rice flour was used? Well, if we look over there, it's 888. So what we need to find out is what how much all-purpose flour was used. That's what we need to find out. Put an F for flour. So the first thing we're going to have to do, it's just like yesterday, wasn't it? We need to add these two up. So let's go ahead and add them up. We'll add 1,802 plus 888. And I like to give a little room right there. So 2 plus 8, 8, 9, 10. There's my 0. Bring the 110 over there. Look at that. 10. Now I can just add 8, 0 plus 8 plus 1. Well, 0 doesn't do anything, but 8 plus 1, 8, 9 is 9. No need to bring anything over. It's below 90. So we can see that 2 plus 88 is 90. But we come over here to the 100 columns. 8 plus 8. What is 8 plus 8? If we go 8, 9, 10, 11, 12, 13, 14, 15, 16, those of you that have your times tables down could just go 8 times 2 is 16. So we're going to put our 6 there and our 1 right there. Now we just add 1 plus 1. We get 2,690. Our next step is to subtract, all right? Our whole, the whole amount of flour we used, we're going to subtract the amount of wheat flour and the amount of rice flour. We'll let you check that out. Get started on it. I know some of you are all saying, Mr. Leggett, you're going too fast. I can't catch up. So I'm going to give you a chance to catch on up. And let's start. 4 minus 0. 4 ones minus 0 ones is 4. I can't take 9 tens away from 7 tens. I can't subtract 90 from 70, so I'm going to need to take a 100 from the 600. This will become a 5, and this will become 17. Okay? So 17 minus 9. Well, think about the difference between 17 and 9. 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 8. So we'll put an 8 here. Once again, we're stuck. I can't subtract 600s from 500s. So I'm going to need to take something from this thousands. And remember we discussed this yesterday. We said, let's not cross that 5 out. Let's just put a 1 right here to make it 15 hundredths. What would 15 hundredths minus 6 hundredths be? Well, 15 minus 5 would be 10, and minus another 1 for 6 would be 9. We're left over here. I can't take 2,000 away from 1,000, so See you later, 1,000. You're going over to the, or 10,000. You're going over to the 1,000 spots. And 11 minus 2 is 9. So there's 9,984. We can round to the nearest thousand to check this number right here. So 12,674 rounds to, well, it's much closer to 13,000 than 12,000. So we'll put 13,000 minus and 2,690. That's closer to 3,000 than 2,000. And we could do this one in our heads. 13,000 minus 3,000 is 10,000. We can see that our answer is reasonable because 10,000 is awfully close to 9,984. So let's finish writing this up. I'm going to scroll up a little bit. They used, the bakery used 9,984 pounds of all-purpose flour. Okay, and we could say my answer is reasonable, as 9,984 is near my estimate. And it's a good thing to copy this to practice these answers. Near my estimate of 10,000. So go ahead and pause that if need be. We're going to continue on, but if you need to catch up, go ahead and pause. Quite all right. And we'll go to our next problem. Okie doke, here we go. Let's read what we know first as we start our concept development. This name is pronounced Sean. It looks like Sion, but it's actually Sean, an Irish name. Sean's school raised, and I forgot the little apostrophe S there, raised $32,587. Less dollars. Leslie's school raised $18,749. How much more money did Sean's school raise? Well, this is a straight ahead subtraction problem, isn't it? But let's do it the right way, the Eureka way. We're going to put Sean here. It's not a straight up subtraction problem, Mr. Leggett. You're giving these children false hopes. It's a big time Eureka math problem. So this is Sean's school. How much did he raise? Bracket time. 32,587. Let's go to our friend Leslie. Leslie's school raised not as much. So we're not going to make our tape diagram as long. Leslie's school raised $18,000, $18,749. So go ahead and set up your tape diagrams like that before we get busy with our subtraction. Remember, this is kind of a how much more tape diagram. This is what we don't know, the amount of money that Sean's school raised than Leslie's school. So let's get started on that right away. We're going to take, let's do a little color combination. I like doing this. We'll say 32,587 minus 18,749. Okay. Now, we could round to the nearest thousand, couldn't we? Let's just kind of do a little crazy rounding up here. So 32,587. Let's round to the nearest, 10,000. So is this closer to 30,000 or 40,000? Well, when we think about 32 is closer to 30 than it is 40, so this would be 30,000. And let's go over here. And 18,749. Well, 18 is closer to 20 than it is to 10, isn't it? So we could round that to 20,000. So right off the bat, I'm going to look over this and say 0 minus 0, 0, 0, 0. 3 minus 2 is 1. This answer should be close to 10,000. But let's see if it is. Go ahead and start if you so desire. We can't take 9 away from 7. 9 ones away from 7 ones ain't going to happen. Simply impossible. So what we're going to do is we're going to decompose these 8 tens and turn them into 7 tens. And our 7 is going to become 17. And 17 minus 9. Well, think about it. 17 minus 10 is 7 minus an additional 1. It would be 8. We come over here, 7 minus 4. What is that? Well, I know that the distance between 4 and 7 is 3, right? 4, 5, 6, 7. So it must be 3. Uh-oh, we have our hundreds. 7 hundredths minus 5 hundredths. Can't take 7 hundredths from 5 hundredths, so we're going to have to borrow, or decompose, excuse me, from the, because borrowing implies that we'll pay it back. We won't. So this 2,000 becomes a 1,000, and our 5 hundredths becomes the mighty 15 hundredths. So 15 hundredths minus 7. Let's count backwards from 15. 14, 13, 12, 11, 10, 9, 8. So 15 minus 7 is 8. Make our comma. 8 thousandths from 1,000 ain't going to happen. Wouldn't be prudent. So we're going to borrow 10,000 from this 30,000, excuse me. It'll become 2 10,000s or 20,000s, while our 1,000 becomes 11,000s. What's the difference between 11 and 8,000s? It would be 9,000, 10,000, 11,000. So our answer must be 3,000. And then we could say simply enough, 2 minus 1, there's 2, minus 1 is 1. And look at that, 13,000 is near 10,000. If we round it to the nearest hundred, we would have been even closer. So let's write our sentence now because we've read, we've drawn. Time to do some writing in the RDW method that is Eureka Math. So we could say Sean's school raised then Leslie's school. So you see why it's important to write that down too, because you're going to be asked to do some problems like that on our big state testing. So Sean's school raised $18,838 more dollars than Leslie's school. How could we check this? Remember how we check? We can add this and this. So I'm going to set the problem up over here. 18,749 plus 13,838. What I'd like you to do is pause the video. Pause the video. There's my little paw. Pause the video, do this problem, then hit start up again, okay? We're going to go on to our next problem. Hungry, hungry hippos. Let's find out what we know. We know a lot of things, Mr. Liggett. Yes, I know you do know lots of things, but we're going to find out even more things like this. Excuse me. A pair of hippopotamuses weighs 5,221 kilograms together. That is 2, a pair. 2 of them hippos weighs 5,201 kilograms. That's a lot of paper clips. The female weighs 2,038 kilograms. We're doing the old, how much more? How much more does the male weigh than the female weigh? Okay? I used to try to draw hippopotamuses on this problem, but I don't think I will. Let's start off with, we can start off with the male or the female. The male's mentioned last, right? So let's do the female first, okay? This is going to be a little different. I'll put F for female. We know how much she weighs. Always best to start off with what you know. She weighs 2,038 kilograms, am I correct? You're correct, Mr. Liggett. 2,038 kilograms. That's the female hippopotamus. Now, we know the male, excuse me, we don't know that. We know the whale, not the whale, the male must weigh more. So let's do the male in green. So there's showing the 2,038, okay? The same amount that the female weighs, for starters. But there's more. Hold that line. So the total weight of the two, this is something else that we know. Let's remember what that was. The total weight was up here, 5,201 kilograms. So the male must weigh more because I know 2,000 plus 2,000 is only going to be 4,000, right? So the male's got to take up that extra weight. And this is the males are more, M for more. What we're trying to find out is how much more? How much more does he weigh? Let's find out. How are we going to find out? Think about this. How in the world can we find this out? Well, let's think. What will we do? Couldn't we take their total weight together and subtract the female's weight? I think we could do that. So let's go ahead and do that. We'll start off with the total weight, which was 5,201 kilograms, and we'll subtract the weight of the female. And this should give us the weight of the male. We can take a look at it already, 5,000 minus 2,000, right? So we know our answer is probably going to be around, excuse me, Mr. Leggett made a mistake. So 5,000 minus 2,000 is not what we're doing. You know why? Because look, we need to add those together first. I could have subtracted it twice, but that would have just gone on and on. So let's add these two together first. Let's add the female's weight. Oh, and I've lost my color code because I got flustered. We're going to add these together. So go ahead and set that problem up. Remember 8 times 2? What's 8 times 2 or 8 plus 8? 16. What's 3 times 2? 3 times 2, of course, is 6, plus that 1 will be 7. And there's 0, there's our comma, and 2 plus 2 is 4. So now we have this done, right, and this done. Here's the more. Now we can subtract. Boy, Mr. Leggett, what are you thinking? I'll tell you what I'm thinking. It's been a long day. So we have 5,201 kilograms, and we're subtracting 4,076 kilograms, okay? Let's see what we get here. I know that I can't take 6 ones away from 1 1, but I can't take 0 tens. I can't decompose. So I'm going to start with my hundreds. And that 2 hundredths is going to become a 100, and this will become 10, okay? But I still have to decompose, right? This is 10 tens, but my little 1 here needs some help, so that 10 is going to become a 9, or 90, and the 1 will become an 11. 11 ones, because we took one of the 10s, all right? Kind of set up, ready to go, it looks like. What is 11 minus 6? Think about the difference. 7, 8, 9, 10, 11. It is 5. And what is 9 minus 7? 7, 8, 9, 2. 1 minus 0 is 1. And 5 minus 4, of course, is 1. So we have 1,125 kilograms. And we could say the male hippo weighs 1,125 kilograms more than the female hippo. Period. So notice how we did that. We first had to add these two together because our combined weight was 5,201. And then with this, the 2,038 plus 2,038, which is 4,076, we had to subtract that number from this number, our whole, and this is what we got left. So if we look at it, 2,038, and 1,125 for the male hippo. Alrighty. Let's go on to our next problem. Hope we have enough digital room in our tape player. It's not flashing warning yet. All right, let's see what we do know. What do we know? What do we know? What do we know? No. A copper wire was 240 meters long. After 60 meters was cut off, it was double the length of a steel wire. Wow, this is like a cryptic problem. How much longer was the copper wire than the steel wire at first? Ay. Here's what we have to try to do. We're going to make a copper wire. How long was this copper wire? Look at our problem. 240 meters long. Remember that M stands for meters. Now let's take a look at our steel. What are we going to put for the steel? It says after 60 meters cut off, it was double the size of a steel wire. So even after cutting off 60 meters, it was still double the size. So we're going to take that 240 and we're going to say snip, and we're going to cut off 60 meters, okay? So the first thing we're going to have to figure really is 240 minus 60, but let's not get to that quite yet. Let's deal with our steel. The steel is only half that of the copper after it was cut. So we're going to come over here and go, how much longer was the copper wire? We got to go all the way over there. How much longer was the copper wire than the steel wire at first? So there's some other things that we're taking a look at. Wow. First thing we're going to do, let's do 240 minus 60, okay? 240 minus 60. What will that equal? I know some of us could probably do this in our heads, right? Think about 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. We take away one of those 6's, or in this case 60, we go back to 180, right? Now we have to figure out what it was when it was cut in half, when it was divided by 2. So we have 180. Remember, this is now 180 right there. And we're going to divide that by 2. And what does that equal? Think about it. 2 times what is 18? Well, 2 times 9, but we're dealing with 180, so it'd be 2 times 90. All right, so now, let's go back to our problem. A copper wire was 240 meters long. After 60 meters was cut off, it was still double the length of a steel wire. How much longer was the copper wire than the steel wire at first? Well, this is what we're going to find out. We're going to take 240, the original length, and we need to minus 90. Why 90? Why 90? Because half of this was 90, right? This is the length of the steel. So half of this was 90. So we're going to get 24 minus 90. Well, 24 minus 9 is 15, but in this case we're dealing with hundreds and tens. So it'd be 150. So the copper wire was 150 meters longer than the steel wire at first. This is at first. So if it was 150 meters longer, the steel wire was how long? Well, we can do 240, right? The total length before, minus 150 would be, well, let's not go there yet. Let's write first. The copper wire was 150 meters longer than the steel wire before it was cut. So it was 240 feet before it was cut, right? So we could figure out the length of the steel wire by taking 240 minus 90 was 150, right? So the steel would be what? Let's take a look. The copper wire was 240 meters long. After 60 meters was cut off, it was double the length of a steel wire. So 180 divided by 2 is 90. See that? We cut off 60 and it was double the length. They want to know how much it was at first, so we know it's double the steel plus the original 60. Kind of a long way around it, don't you think so? And it looks like we are still good. We got about 5 minutes to go, but I think we're going to stop right there so I can load this puppy up, and we'll get ready for our problem set.